Okay, so we're just going to start off by solving this. We're going to factor the denominators. I'm going to state the restrictions. Okay, we're going to figure out the lowest common denominator, right, which is going to be x times x plus 1. And we're going to multiply every term by x times x plus 1. And I like to put that over 1. Equals. Minus. And remember, you don't necessarily need to show this step. You have to decide whether or not this is something you need to show. Okay, so we're going to cancel these, and this, and this. And the idea is 1, 1, 1, 1, 1, 1, 1, right? So that we have a denominator which is just equal to 1. Now we can go through, we got 1 times 1, so we've got x squared minus 4 is equal to x times x plus 4 minus x plus 1 times x minus 7. Okay. Yeah, all we need to do here is expand this, but be careful, especially because there's a minus sign. Oh, you writing something? Gotta just hang on a minute. Minus, okay, and I'm going to put down a set of brackets, so I'm going to expand that. I'm going to expand that, but I'm going to keep the minus sign there. That's good. All right, so we've got x squared minus 6x minus 7. Okay, so let's take our time here. Minus x squared plus 6x plus 7. Okay, so x squared minus x squared, those are gone. So I got x squared minus 4 is equal to 10x plus 7. Let's drag that down. It's going to be x squared minus 10x minus 11 is equal to 0. And we're going to factor that, and then we're going to solve, right? So x equals 11, or negative 1. And now we want to, is the one of those a restriction? Yeah, which one? Can't be negative 1, right? And then the important thing is go back and check, right? Okay, so write this down. I want to see this, right? And then just X it out. Okay, and if you want, you can just write restriction or something. Okay, so the solution is x equals 11. Right, and then that's checkable if need be. Okay, real stuff. Application. The sum of two numbers, it's big. Yeah, it's like big. It's like in a different font than we're used to. We're like Times New Roman, but this is like Arial or something. Anyway, well, it's a very important question. The sum of two numbers is 16, and the difference of their reciprocals is 1/15. Determine the value of the two numbers. Okay, what's determine mean? Show your work. Okay, so we got to show some work. So, step 1, label variables for what you are trying to determine. Okay, what are we trying to determine? Two numbers. Okay, so what are the numbers going to be? We could do that, but we actually know a little bit something about it. So let the numbers be x and 16 minus x, right? So we know that these two numbers add up to 16. So you could say, all right, okay, x plus y equals 16. So y is equal to 16 minus x, and then just go down here and say 16 minus x. All right, so if you want to introduce the other variable, just kind of do it on scrap paper or whatever, right? Because we don't really need two variables here. But if you need to, just the other one's going to be y. I know that x plus y is 16, so y is 16 minus x. So everything's just in terms of x here, right? Make sure there's brackets around this. Actually, they're parentheses, brackets with the brace thing. Write an equation for the variable you're trying to determine. Okay, what do we know about these two numbers? Okay, we know the sum is 16, so we've used that in order to do this, right? Okay, and the difference of their reciprocals is 115. So how am I going to write that?
1 over x minus 1 over 16.
Yeah, so 1 over x, so that's the reciprocal of the first number, minus 1 over 16 minus x is equal to 1 over 15. Right? So first step, label the variables. Maybe a little bit of work here, just kind of figuring out, okay, what's the other variable going to be? Now, it could be a diagram, it could be a chart. We do a lot of charts in this stuff, right, and filling in. Solve the equation by factoring, completing the square using the quadratic form. Well, we actually have to get an equation. So write an equation, you may have to do some extra work to get the equation in terms of one variable. So we've got the equation in terms of one variable. Right? So here we could state restrictions, right? What can't x be? 0 is 16. Now we don't really have to worry about that, right? Because the reciprocal of 0 is undefined, so we know 0 is not going to come out as a solution, and 16 won't come out as a solution because this would be 0 and then be undefined, right? So we shouldn't have to worry about getting an extraneous solution to this. All right, so what do we do? Yeah, so what's the LCD? Are there any numbers in the lowest common denominator? 15. And then we need, right. Okay, so that's my LCD, right? 15, x, 16 minus x. Hard way or easy way? All right, let's do it then. Let's do it the hard way. It's not the hard way. It's the more detailed way. We'll do a detailed solution, right? So our LCD is this, and I put it over 1, and I multiply it by the first term. Minus, and I put my LCD down again. And I like to put it over 1, right? Because I like to see all the denominators. 1 over 16 minus x equals, LCD again. Getting a little smaller this time. Okay. And we go through, cancel, 1, 1. 1, 1, 1, 1, 1, 1, right? 1's the denominator. Okay, you don't necessarily have to show that line, right? But, you know, you figure it out. If you're getting them all right by not showing it, then that's fine. And if you are not, then do this. Okay, it doesn't hurt. So I've got 15 times 16 minus x times 1. I'm not going to write that in. Minus 15x times 1. So I'm going to say minus 15x is equal to x times 16 minus x. Okay, so for some of you, that might have just been the next line that you wrote. Okay, what's 15 times 16? It's going to be like 240, right? 240 minus 15x minus another 15x is, I'm going to go with negative x squared plus 16x. Okay, so do a little bit of collection first. Minus 30x. Okay, move these guys over, so we get x squared minus 46x plus 240 is equal to 0. So that probably factors, right? Because we're looking for numbers. All right, so 10 hours multiplied, 240, 10 and 24. No, so we got to also add up to 46. 6 and 40? That's just too obvious. X minus 6, so I write 60, right? Yeah. Okay, so I have two solutions, perhaps. Neither of them are restrictions, so at the very least I need to go and sort of check these out, right? So we'll put a 6 in here. I would probably just do that with a calculator, right? So just go 1/6. I don't have a calculator handy, so it's going to be 1/6 minus 1/10 is 1/15. Common denominator is going to be 30, so this would be 5 over 30 minus 3 over 30 is 2 over 30. Okay, that's true. I mean, I can see that. And then we want 40, right? 1/40 minus 1 over 16 minus 40 is equal to 150. 1/40 minus, this could be like plus 1/24, right? 16 minus 40 is negative 24, so it's going to be minus, and so that'll be a plus. Equals 1/15. God only knows what the common denominator is for those guys. All right, what's the common denominator for 40? Well, actually, you just plug it in your calculator. Just go 1/40 plus 1/24, hit enter, go 1 divided by 15, hit enter, and say, hey, they're the same. Or they're not. Huh? Good. They should be. Okay, write your answer in sentence form. What was the question? No, seriously. So determine the, okay, so the two numbers are, now the two numbers are 6 and 10 and 40 and negative 24, right? Or sorry, 40 and 16 minus 40. Yeah, wait, what? So, oh yeah, the sum of two numbers is 16. Yeah, okay. So the two numbers are, or the numbers are, 6 and 10, or 40 and negative 24. Okay, does that match up? Yeah, so the two numbers whose sum is 16, so 6 plus 10 is 16, and 40 plus negative 24 is 16, and sum of the reciprocals is 150. Okay, questions? So it's kind of a number problem, right? So we're going to have various problems. You're going to get to spend the weekend doing various problems, right? So one type of problem is number problems. Here's another type of problem. I know. It's like big, and it's sans serif. There's no serifs. I mean, how are you supposed to do this? How can you read this stuff? The 36 students of Miss Tong's classes used to be larger, and they'll be larger next year as well. 36 students of Mrs. Tong's, she's retired now. Math 20-1 class, each contributed an equal amount to buy Mrs. Tong a fabulous gift.
Wow.
However, 6 students got mad at Mrs. Tong for taking away their cell phones and refused to contribute to her gift. As a result, the remaining 30 students had to contribute an extra $1, which they were very happy to do. Determine the value of Mrs. Tong's gift. Okay, so when we solve word problems, you're going to read through it. And the first thing we got to say is, all right, well, what are we trying to find? The value of Mrs. Tong's gift. So that's going to be our unknown, right? So we're going to say, let X be the value of Mrs. Tong's gift. So now we need an expression. So if the value were, and I'm going to pick a number that's divisible by 36, right? So if the value were $36, how much did each of the initial students give? $1. If the value were $72, how much did they give? $2. So if the value is X, how much did they give? X divided by 36, right? So if you say, hey, if it was $72, then they each had to give $2. If it was $108, then they each had to give $3. So each student initially gave x divided by 36. So initially, each student gave x over $36, right? Now, six of them decided not to contribute. And so the other 30 students had to contribute an extra $1. All right, so how are we going to come up with an equation that fits this information, right? So initially each gave this. We end up with $30 contributed. Now the value of the gift didn't change, right? Okay, so x over 36. Okay, so that's how much each gave. So let's say that x was $72. They each gave $2, right? But now they each have to add another $1, right? So this is a number of dollars, right? Okay, and now they gave an extra $1. Okay, now, so how much did each contribute in the end? Well, so what are we left with? We still have x dollars, right? But how many ways are we splitting it now? 30 ways. Okay, so obviously it wasn't $72, right? But if it were $72, then okay, each of them gave 2. Now they had to add an extra 1, and that's their share of the gift, right? So it's like x divided by 30. So the price of the gift didn't change. But this is how we do it, right? So x over 36, that's how much each initially gave. All right, oh, but wait, now we got to add $1 because they each had to kick in another $1. And that's going to be split 30 ways, x over 30. Okay, and this is what we want to solve. Okay, there's no restrictions here, right? It's actually fairly easy to solve. What's the lowest common denominator? So you could do 36 times 30, right? I don't think we have to go quite that big. It's just going to be 180, right? It's like factor, right? So 36 is 6 times 6, and 30 is 6 times 5, so I'm going to need 6 times 6 times 5. So the LCD is 180. It seriously wouldn't matter if you did the LCD as 36 times 30, right? Because it's just going to factor out and solve. Okay, so we're going to multiply everything by 180. So 180 times x over 36 plus 180 times 1 is equal to 180. Okay, so that goes once, 5 times, nothing cancels there, that goes once, oh wait, that's 6 times, and that goes 5 times. So 5x plus 180 is equal to 6x, so x is 180, right? It's just going to be 6x minus 5x. So the value of the gift was $180. Okay, now the fourth step in George Polye's problem, so I'm going to look back. Okay, so 36 students. So what's 180 divided by 36? 5. So initially they each kicked in $5. 6 kids withdrew, everybody had to put another $1 in, so initially they kicked in 5, now they've got $6, but there's 30 of them, 6 times 30 is 180, okay, solved, right? It works. Questions? Susan plans to run a 12.2-mile course in 2 hours for an average speed of 6.1 miles per hour. It's got nothing to do with that. For the first 8.4 miles, she plans to run at a slower pace. Then she plans to speed up by 2 miles per hour for the rest of the course. Determine the slower pace that Susan will need to maintain in order to achieve her goal. All right, the infamous distance, speed, time problem, right? Math is full of distance, speed, time. You might do the odd one in physics as well, I guess, but. Oh, there's a lot of them in physics, is there? Okay, so distance, speed, time. Here's what you should do for every distance, speed, time. Set up a chart. Yeah, always set up a chart. And your chart is going to have distance, speed, and time. And we've got the slower pace and the faster pace. Okay, so at the slower pace, how far is she going to go? 8.4 miles, right? At the faster pace, how far is she going to go? 3.8, right? So where did 3.8 come from? Yeah, 12.2 minus, okay? So really all we're doing is sort of consolidating the information that's in the question. Now, how fast is she going at the slower pace? Don't know, right? You said you're supposed to, don't give me the answer yet. Let's reveal this slowly. So we don't know, right? That's our unknown, so we're going to call it x. How fast is she going at the faster pace? 2 miles an hour faster, right? Than she was. So what do I put under the faster speed? X plus 2, right? Okay. So I don't know what x is, but I know that x plus 2. Okay, how are distance, speed, and time related? First cousin? Nephew? Yeah, well, I don't know. Well, there's a relationship between them. Aunt and uncle? What's distance? What's distance equal to? Speed times time, right? So, let's just do the old, for some reason, God only knows why, you're going to drive to Edmonton. Right? So we all know, how far is Edmonton? 300 kilometers. Takes us 3 hours. We're going about 100 kilometers an hour. So the distance, 300, is equal to 3 times 100. So that's how you, so distance equal to speed times time. We don't need that, right? We need time. What's time equal to?
Distance over speed.
Yeah, so you rearrange this and you get time is distance over speed, right? Now, we know how long she wants to take to do this, right? So what's this time? 8.4 over x. And what's this time? 3.8 over x plus 2. Okay, now we got to set up the equation. What's the equation? So the time at the slower pace plus the time at the faster pace is equal to 2. Big thing to make sure of is that everything's in the same time units, right? Which they are, right? Because she's going to speed up by 2 miles per hour, you know. So if they're mixing hours and minutes and stuff, you just have to get everything into the same time units. In this case, it's everything's hours, so it's all good, right? So this is miles. This is miles per hour. You divide miles by miles per hour, you get hours, right? Miles divided by miles per hour becomes hours. So this is the time she's going at the slower pace plus the time she's going at the faster pace. And that's the total amount of time that she's going to take, right? So that's the relationship, right? So distance, speed, time, always set up the chart. Get your expressions for distance, speed, and time. It's almost always this, right? It's almost always time is distance over speed, right? And it's almost always you've got a relation. Now they might say that, you know, she wants to run the same amount of time. So they don't give us 2 hours, but they say the times are equal. In this case, you just set these two guys equal to each other, right? So you will get questions where, you know, so-and-so is driving to Banff and then driving home, and they can drive home faster because they drove at night and there was less traffic. And so, you know, or they could go to Banff and they could go to some other place and the times would be the same, but they could drive faster going to the other place. So just be aware of what the relationship is. Are they giving me a total time? Are they giving me a difference between the times? Okay, so it could be I went by bus and somebody else went by car, and the car was an hour, it took an hour less time, right? So just figure out, well, this is the bigger time minus the slower time equals 1, okay? Okay, so what's our restriction? Yeah, okay, I don't think we really have to worry about her speed being 0 or being -2, right? Alright, okay, don't have to worry about that, but Yeah, just going negative, just going backwards. 2 miles. What's our LCD? X times x plus 2. Okay, so 8.4 times x plus 2 plus 3.8 times x is equal to 2 times x plus 2. Well done. Excellent. Thank you. Well, look at that. Question on the bottom of this page is set up a rational equation. Seriously, set up a rational equation. All right, let's solve this. But it's got decimals. And it's got squares. Oh, yes, okay, seriously? All right, so what's that? Oh, that's going to be 12.2, right? Okay, what do we got? 2x squared minus... No, that's going to be a minus, right? Well, everything's divisible by 2, but then we don't get really nice numbers. I could multiply everything by 10 and then divide by 2, or I could divide by 2. And then multiply by 10. Do you think that factors? Maybe it does, maybe it doesn't. It doesn't. All right, so x is equal to negative b plus or minus square root b squared minus 4ac. Okay, so always write the formula down. So x equals, so we can have decimals here, it's not a big deal. 4.1 plus or minus the square root of, that's a negative 4.1. Make sure this is in brackets and it's squared, and when you just go to square the 4.1, don't put the negative with it. It's just going to be a positive. Minus 4 times 1 times negative 8.4 all over 2 times 1. Does it say determine the slower pace? All right, let's just go to a decimal. So 4.1, let's go to 1 decimal place. So what's the square root of 4.1 squared plus that? Like 7.1 or something. This calculator, anyone? Work this out, square root of.
It's 5.6.
The whole thing is 5.6? It's like after it's all worked out? Or? All right. So it's 5.6 or negative 1.5. Okay. Show it, right? X could be equal to negative 1.5. Cross it off. So yeah, you can't do that. Okay, can't have a negative speed. So her speed is 5.6. So Susan's, I want to determine the slower pace. Susan's slower pace. Say that 5 times fast. Susan's slower pace is 5.6. No, miles, right? With miles. Miles per hour. Okay, now forget everything we've done. Go back up here. For the first 8.4 miles, she plans to run. So what's 8.4 divided by 5.6? Sorry?
1.5.
1.5. And what is 3.8 divided by 7 point? I can do that. That's a half. So 1.5 plus 0.5 is 2. Okay, so it matches, right? You go back to the original question here. It's all right, so 8.4 miles at a pace of 5.6 miles per hour is whatever he said, 1.5, and then 3.8 divided by 7.6. So it was actually, was it exactly 5.6?
Yeah.
Oh, so that means that would have factored if I had multiplied it by 10. No, you can't factor everything. Colleen can shovel the walk in 50 minutes, but Henry could shovel the walk in 30 minutes. Yeah, well, Colleen is actually Mrs. Tom, and Henry is Mr. Tom. Determine how long it would take the both of them to shovel the walk together. So this is a rate problem, rate of work problem. You will see it under various guises. So one of them is this. It could be, Joe working by himself can paint a room in 2 hours, and Susan working by herself can paint the same room in 1 hour 45 minutes. If they work together, how long does it take them? Okay, or it could be Joe can mow the lawn in 2 hours. Working together with Bill, it takes them 35 minutes. How long would it take Bill working alone to mow the lawn? Right? I mean, just so it's rate of work problems. Okay. So the way we need to think about this is to say, all right, if it takes 50 minutes for Colleen to shovel the walk, then how fast is she working at? How much of the walk can she do each minute? So it takes 50 minutes. So what's her rate of work? She can do, 1/50th, right? 1/50th. So she can do 1/50th of the walk every minute. Okay. What's Henry's rate of work? He can do 1/30th of the walk every minute. Okay. So it's a rate of work problem, right? The same thing comes. A garden hose can fill the pool in this long, but using a fire hose it takes this long. If we've got them both going, how long does it take? Right? Now, this, in theory, that works for a certain number of things that can be done, right? In other words, if we apply more manpower to a job, then it can be done in less time, right? However, we cannot get 9 women working together to have a baby in 1 month. Right? Certain things take. There's a book by Richard Brooks called The Mythical Man Month, right? And the idea is this, right? So a lot of you guys, you may go on to be engineers or whatever, right? You're working on a project and you're saying, you know what, if we get a couple more people working on this project, we can finish it this much earlier, right? But sometimes you can't. I mean, sometimes there is a task which is going to take this long regardless of how many people we have working. And actually, if we get too many people working on it, it's going to take longer. Right, that's better. So there are certain tasks when you're doing stuff where it's just, you can say, look, it's going to take, right? It's going to take 1 woman 9 months to have a baby. We cannot say, hey, let's get 3 women working on it, we can get this done in 3 months. It doesn't work that way, right? And so the guy who came up with it was in regards to software projects, right? So if you're doing a software project and you just say, oh, if we get more people working on it, it'll happen sooner. Yeah, maybe not. Okay, maybe it'll slow things down. Okay, but shoveling the walk, yes, for sure, right? I mean, if more people work, we know, yeah, that's going to happen fast. Now, if we get like 15 people working, they're going to get in each other's way, right? So that's the idea. But in this case, rate of work problem. Okay, so Colleen can shovel 1/50th of the walk per minute. That's her rate of work, right? Henry can shovel 1/30th. Suppose we could throw a th in there. 30th of the walk per minute. Working together, how long does it take them? Okay. So the setup is that working together per minute, they can do one. So we're going to say let let t be the amount of time. It will take for the walk to be shoveled if they work together. So working together, how much of the walk can they do each minute? 1 over t, right? So Henry alone, or sorry, Colleen alone, 50 minutes, 1/50th of the walk. Henry alone, 30 minutes, 1/30th of the walk. Working together, we don't know, so that's our unknown, right? Determine how long it take both of them to shovel the walk together. So working together, that's our unknown, t, be the amount of time. And they could do 1/10th of the walk, 1t. Okay, so we could say 1 over 50 plus 1 over 30 is equal to 1 over t. Okay, so working together, they have a particular rate. That's going to take them t minutes, right? We're just going to solve for t. So t can't be 0, which it can't be anyways. You can't do the walk in 0 minutes. Unless you're in Los Angeles or something, and then you're not shoveling walks, right? Yeah, it doesn't snow here. What's our LCD? $150t, right? If you use 1500, right, if you just went 50 times 30, you know, you're still going to solve it. It won't be that much more, it won't take that much longer to solve, right? It's just, you're going to have numbers that you don't need. Okay, so 150 over 1 times 1 over 50 plus 150 over 1 is 1 over 30 equals 150. Oh, sorry, 150t. T equals 150t over 1 is 1 over t. Okay, t's are gone there. Got a 5t, 3t. 3t. So 3t plus 5t is 150. 8t is 150. And t is 150 over 8, which is 75 over 4. Now, we gave stuff in minutes, so we should really, so what is 75 divided by 4? 18.75 minutes equals 18. So it's acceptable to go into decimals here, right? So 18, so it will take 18 minutes and how many seconds? Well, 0.75 is 3/4. 3/4 of a minute is 45 seconds. Right. So you could go into minutes and seconds. It could be in hours. You know, you could have like 3.2 hours. How long is 3.2 hours in minutes? Or 3 hours, how many minutes? What's 0.2 of an hour? 12, right? You just go 0.2 times 60, right? You just multiply by 6. So if you have a decimal portion and you want to change, so if it's decimal minutes multiplied by 60, you'll change it into seconds. If it's decimal hours multiplied by 60, you'll change it into minutes. Good. Is that all there is?
Yeah, that's
Woohoo.